today's video is going to be about the TP-Link 500 megabit per second Powerline Ethernet adapter. This is a unit that plugs into the wall and theoretically can transmit Ethernet signal over your power lines up to 500 megabits per second. I just got these. They come as a pair, and haven't even peeled the foil off of it yet. But I've noticed that on one of the units, whenever I would move the cable just a little bit or move the adapter just a little bit, I would lose all power to the device. And through trying it in several outlets, I discovered that there's a problem between the two lugs that are on the back side of the unit and the circuit board that actually accepts and transmits the signals back and forth and decodes them and whatnot. So today's video is going to deal with how to fix this particular problem, and you'll probably lose your warranty if you do this. So if you find it to be a problem, you could send them back and get warranty repair, but chances are the ones you get back are going to be just as bad as the ones you got, unless they change their manufacturing process. This is again the TP-Link 500 megabits per second Ethernet Powerline adapter, and I'm going to show you how we can repair them without having to send them back. If you've got some basic tools and little patience and a little skill with soldering, it shouldn't be much of a problem. Alright, to perform the repair on this TP-Link 500 megabits per second device, of course we need the device. We're also going to need a roll of clear flux solder. We're going to need a pair of long nose pliers. And we're also going to need a jeweler's screwdriver. And of course we're going to need a soldering iron. Now, soldering irons come in many different sizes and shapes. I would suggest a pencil iron like this one. It's very low wattage and will prevent you from damaging the device. This is our TP-Link 500 megabits per second device. What we're going to do is flip it over, and you will notice down in this corner and in this corner are two black screws. And you're going to need a jeweler's screwdriver to get them out. So let's go ahead and remove them. They're in there pretty tight. There's one. And yours won't have the yellow paper on it. I did that just to protect the MAC address and serial number out of the device. Alright, so now we've got the two screws out of the holes, and like I said, they are pretty small. Now the rest of this assembly actually has little plastic clips on the inside of the white, and the white actually will expand into the sides of the black part. So what we need to do now is separate these two. Now you'll find that on this particular device here, this plate that's part of the bottom will actually slide up, and we don't really need that to come up. What we need to do is to try to hold the circuit board in place, and if you have good fingernails, that will help as well. And what I'm going to do is work these down both sides and separate them with my fingernails until we can get this to begin to pop loose out of here. I've not taken this one apart before this minute, so it is going to be a little bit difficult with me. What I'm going to do to actually get this one apart is use a very narrow flat blade jeweler's screwdriver, and I'm going to begin to work it down the sides here to try to break it loose. And here we go. So you can see I'm just prying this open a little bit. Again, once you get it started, you may want to kind of stick your finger in there so you don't have it come apart on you. And again on this side, same game. Alright, and it's starting to come apart. I can kind of hear it moaning and groaning and popping and clacking a little bit. Alright, and this side went back in, so you'll have as much fun as I am trying to get these out. Now what you could do is work out this side and then get another screwdriver and begin to work the other side, and that might actually be a little bit easier to do. There we go. Okay, so now we've got both sides working here, and again we want to kind of just get these to separate. Now once you get down the side here, you're going to have a couple more of these little retaining clips here that need to release. There's one near the top, so you can see this one up here. And now this part here actually has fingers that go into the black part, and they go straight in. They're not angled at all. So we want, ideally, we want to slide this straight off the top here. And again, just carefully work this out. I'm going to use a little thinner driver along here, so I don't want to break it. We're going to put it back together exactly the way it came apart. Alright, and as you can see the little fingers here that actually interlock with the plastic? There's another one right down in here. It's kind of hard to see, but you might be able to see it in here. Alright, there we go. And eventually this should release here. Got to release both sides. There we go. Now inside they've got some things that are kind of glued in here. There we go. Alright, now, so what I'm going to do now is just simply lift this off, and you see that there are rubber parts on here. These, I believe, are acting as not only pads to hold the circuit board in place and keep it from moving, but I think they double as heat sinks. And you can see that they're attached to metal fingers here, and they keep pretty good pressure down on this assembly. Alright, so what we're looking at now is the inside of this device, and let me just set this here for just a second. And what we're looking at is at the top, right here and right here, are two solder joints. And these solder joints are tied to an intermediate piece of metal that's ultimately attached to the two blades of the outlet here where they actually plug into the wall. So here in the US we've got these type where they're just blades that plug into the wall. In your country you may have something different, but that's what we've got here. Alright, so the next thing that I want to do is I want to heat these with a very small amount of heat, and the way I'm going to do that is I'm going to actually take a real heavy pair of long-nosed pliers, and I'm going to just squeeze one of the legs, and it will act as a heat sink, and I'm going to remove the solder from this part of the assembly right here, and also this part over here. When I do this side, of course, I'll remove it off of there. Now, a couple of different ways that you can get this out of here. There is something called solder wick that you can use to remove it. There's also solder sucking tools that you can use to remove it. I've found that it seems to work good to just simply heat it up and flip it over and just tap it, and the solder will fall out onto the table. And ideally you want to try to get as much of that out of there as you can. Again, don't hold the heat on there very long. We want to remove these without damaging any of the assemblies. The other thing that you can do at this point is to remove this little plate out of the bottom. Watch the little switch here. You can separate this a little bit. Oops, and out it comes. Okay, so it just pops out. It's just a little plate, and it has a hole for the switch, so be careful about the switch. Now you'll notice once you get this out that this assembly moves really easy, and the reason it does that is because of the way these two top parts are anchored to the bottom. And so I'm going to remove the solder from these two device areas, and then go ahead and do that. Now, the first thing I need to do though is heat up my iron, so I'm going to pause this video for just a second. Okay, so at this point, again, what we're trying to do is we want to remove the solder from this lug here that has L next to it, and there's another lug over here that has an N next to it, N for neutral and L for line. And the way we're going to do that is we're going to heat these up with a pencil soldering iron. Again, this is a very simple soldering iron, and I've got it heated up. I'm going to put just a little bit of solder on the tip here, and put a piece of paper under your work so that you don't damage the surface underneath. And now what I'm going to do is I'm going to heat this just a little bit. I've got the soldering iron in the other hand here. I'm going to heat this just a little bit, enough to just get the solder melted, and then I'm going to tap it. There we go, solder's melted, and we tapped it and we got a lot of it out. Let's try this once again. One more time. Alright, and that one's out of there. Alright, now we're going to do the second side. Again, this only takes a second when you don't want too much heat on there because you don't want to damage anything. Alright, and there we go. Okay, so you can see most of the solder that came out of it is laying here. And so they're not totally and completely cleaned out yet. So the next thing that I found works pretty well is to simply heat the joint and then use your jeweler screwdriver to lift up on the circuit board and have the lug pass through. Again, be careful not to melt the plastic underneath. You may have to do this in a couple little steps. So there, I've lifted it to the top of the lug, blow it on it to cool it. Alright, this is a little more difficult to do when you're not in the right orientation. Alright, I'm going to put a little pressure under the board with this jeweler screwdriver, and I'm going to heat it again on this side. And again, just want to get it hot enough to lift it off of the assembly here. There it goes. Alright, and we'll come back here one more time with this side. Hopefully you can see this. Again, I'm just putting enough heat and pressure on it to get it to break loose. And when it cools, it'll reconnect, but it will be further up the lug. Alright, one more time over here. There we go. And that one's free. And we'll do this one over here. Heat it up just enough to get it to break free, and it's free. Alright, so now you can see in this picture that the circuit board is now detached from the two lugs. Alright, let me put my iron down here. Alright, now the next thing we want to do is underneath this assembly is a black plastic heat shield up this one side, and it extends underneath the entire circuit board. So we're going to just simply lift this out. Now you may have to work at it a little bit because there's some more of these glue things on the bottom that want to hold it in place. There we go. And you may have to separate them. Alright, here we go. Alright, now it's out, and you can see that we've got a couple glue things in the bottom here, and here's one on our circuit board. Now the one on the circuit board probably belongs in this hole here, so I'm going to simply remove it from here. I'm going to remove it from here and put it over onto the circuit board. You'll find they're a little sticky. Not horrible, but just a little bit sticky. There we go. Okay, so now they're all together. And now I'm going to lift out, let me get the circuit board out of here for just a minute. Alright, now I want to lift out this plastic protective thing. It's just a shielding, and there's a metal shield under it as well. You can remove them as a unit, and that's kind of what it looks like. Alright, so it's a black plastic, got the three little rubber things on it, and let me zoom out here just a little bit. Might make it easier to see the entire assembly. Alright, so this metal piece is not permanently attached. It's actually got holes cut in it, and the heat passes through these plastic things to the metal, and this acts as a heat sink to help cool some of the components. So we'll set that aside. Alright, and now you should be able to see the biggest problem that we have with this thing. Let me see if I can zoom in here a little bit. Don't want to get too far or we'll get fuzzy. Alright, there we go. Alright, now here's the problem. These little metal clips, as you can see, are not attached tightly to the AC lugs. They are just simply put in here, and then they spread the fingers on these AC lugs. Let me give you a little different angle here, you can see them. Anyway, at the top of the AC lug, they took just this metal part and they split it in half this way, and they bent one this way and one that way, and you can see that possibly get my view right in this view. Yep, see how they're split? The problem is since they're split, they're supposed to be nice and firm and hold these in place, but they don't. They're just in here flopping around, which is really irritating because that means your signal's coming and going and you're making and losing power connection, and that's never good for a stable signal. Alright, so we're going to fix that, and I'll show you how we do that in just a second. Alright, before we fix this, one of the things that I want to do is, you'll notice that on these lugs there's leftover solder from where it was soldered to the main circuit board. So one of the things I like to do is remove as much of that as I can before we do any of the other work. So I'm going to do that with my pencil iron, and again we're simply just going to heat this little lug up and then tap it, and all of the solder just kind of falls right off of it. There we go. So now they're nice and clean, no solder on them. And so now the next thing we want to do is, you can see these are nice and clean now. There's no solder left on them. Next thing we want to do is solder these little plates to the bottom lugs that are on the bottom here. Now, two problems that you have to be concerned about. These lugs have to fit back into the circuit board whenever we put it back together, and we don't want these lugs to get so hot as to melt the plastic in the casing assembly. We don't want that to happen. So we're going to use the long nose pliers to act as a heat sink, and we're going to squeeze this lug with the pliers. The other thing that we want to do is we want to shim these up, because you can see they're kind of loose and floppy in here. And so what I'm going to do is I'm going to put a piece of paper between the black skin and the lug to lift it up, and that way it will be easier when it comes to reassembly, because these will be higher than they were originally, and they can slip through the holes in the circuit board a little bit easier. Alright, so let me get my little paper shim, and we'll form that out of just a sheet of paper and stick it in there. So hang on one second. Alright, so now I've got, I just fashioned just a folded piece of paper as a shim, and what I'm going to do now is slip it right in here between the plastic housing and the metal clip that they have anchoring this together. Alright, and then the next thing we're going to do is we're going to take the pair of pliers, and be careful, there's some of these pliers have cutters on them. We don't want to cut them. We just want it to act as a heat sink for us, and we'll just squeeze them together. Now some people like to put a rubber band around them. That works good. You can actually put a rubber band around the pliers handles to hold them together, and that way they act as a heat sink. In fact, I'm going to do that here. Okay, so we've got the assembly here. So the next thing we're going to do is I'm just going to put this rubber band around the handles here. A couple wraps is all you need, and what that does is it kind of spring loads them, right? And now I'm going to take them and I'm going to put them, open them up a little bit and just slip them onto one of the lugs that we have on here. And now what's going to happen is that as the heat passes through that lug, this lug on this side, it's going to act as a heat sink, and it'll suck the heat away before we have any damage occur to the plastic. Alright, and again you can see that we have this all put together and should be ready to go. Alright. Okay, so now we've got the heat sink in place. I've supported the other end of the casing here with just the circuit board itself, nothing fancy. And so the next thing we're going to do is we are going to heat up this left side here that we're working on, and we're going to apply some solder to it, and you'll see we're going to solder this little tin plate to the two legs that stick up here out of the circuit board. So I'm going to heat the legs first, and I do that just by simply placing a little heat on here. The tin will heat very quickly, but the legs will take a little bit longer. And I'm applying a little bit of solder, and you want it on there just until the solder begins to flow. There we go. And maybe a little more. And again, we don't want to get it too awfully hot. We just want a good solid electrical bond. Alright, and maybe a little more solder. Again, you can't have too much solder, I don't think. Alright, and kind of blow on it there, let it cool a little bit. And that's pretty good. Maybe just a tad more over on this side. That big heavy metal part cools very quickly. And there we go. Alright, so that one's done. We'll give that just a second to cool. And it doesn't have to be pretty, just want to make sure that it's nice and solid. Alright, and because this pair of pliers pulls the heat off pretty quickly, you really shouldn't have any, see there's no plastic melting or anything on the outside. Alright, now we're going to go to the other leg and do the same thing. And I'm going to take my little shim here and I'm going to move it over behind this side. There we go. It's kind of blocking our light a little bit, but that's alright. Alright. And again, we're going to heat the leg and the tin, mostly the leg, because we don't want the tend to get hot before the leg, but we want the leg to get hot. And since it's a thicker metal, it's going to want to get hot fast. Alright, now we'll go on the metal and add a little more solder here. Alright, there we go. Let it wrap around a little bit, and I think that's going to do it. Blow on a little bit, let it cool, and I think we are going to be in great shape here. That's the extent of our soldering for right this second, till we get the assembly back together. Alright, so we'll set that off to the side, let it cool a little bit. As you can see, it's, can pull our paper out, you can see it's nice and firm now. See, these don't wobble anymore. They're fixed in position. May have to adjust them up or down a little, or front or back just a little bit, but that's going to work out real nice. Alright. Okay. So the next thing we want to do, we'll set that off to the side, let it cool. And it's happy over there. The next thing we want to do is remove the remaining solder from the circuit board itself. And as you can see by looking in here, we want these channels to be open. Now we can get to both sides of the circuit board, and it looks like we got most of the solder out of there. Again, the way I'm going to do that is just heat it up a little bit and just tap it on the table, knock the solder out of it. Be careful, you don't want solder to splash on yourself or onto any of the other components, because then you can create electrical shorts and things like that, and that's never good. So again, just a little bit of heat is all we need, and make sure your iron is nice and clean. Alright, and this one I got most of it out of it when I first started working with it. So it's pretty well opened already. Alright, and then we'll do this other side. This one has a little more solder in it. Again, working very carefully. Alright, so they look like they're open pretty good. Alright, should be wide enough to get original blades back through there. Okay, if it's not, we'll just touch it with the iron just for an instant and get them back together. Alright, and again, make sure these small balls of solder do not get on anything. You can make sure to clean your dust surface and throw them away before you continue. Okay, so now we've got our case back on the table, and this is nice and cool. The little fingers are nice and clean, and they are approximately equal distance from the case housing. What we're going to do is we're going to also check the circuit board, and again, we've cleaned that out. The holes are nice and clean right here and right here. And so what I would suggest that you do is to dry fit these before you do anything else, and just to make sure that everything lines up. And you'll notice that as you're putting it together, there's little grooves in the side of the circuit board, and also there are grooves in the side of the case, little fingers that are sticking out, and you want to line them and just kind of slide them down evenly all the way to the bottom. Now, once you get to the bottom, the object is to have these blades slide into the holes that are here, and you may have to push the blades in or out a little bit, or left or right a little bit, to get them to align. But once they align, just put a little pressure down on the board. They should slide right in there. There you go. Alright, so see how that's down in there real nice. And it should be pretty easy to solder once we get to that point. Alright, so now we've got to remove the board and put the heatsink elements back into the bottom of the container and make sure that they are where they're supposed to be. Again, remember that these had the heatsink rubbers on them to convey the heat to the rubber to the metal plate, so make sure this is all back together. If you recall, these little flaps were to the left here, so we're going to just simply slide them in, and again they also have the notches and the grooves on them just like the case does, so if you line them up it's kind of hard to make a mistake. And push them all the way down. Alright, now you'll see there's an alignment finger down here on this side, so make sure that that goes over, and then there's a little nub in the center, and everything else looks good. Alright, so we have no other parts left over. Next thing we're going to do is kind of hold the circuit board and this piece together here and kind of line them up. Now we don't want this all the way to go down yet because we've got, if you remember, this part with the hole in it for the pairing button, and so what we're going to do is we're going to actually slide that over there, and then this will slip into a groove. Need a lot of hands to do this. Alright, and there we go. So that's how that goes back together. Oh, that's how that goes back together. Alright, so it's nice and flush, and it just slides in there. And we've got this part back in here. Now once again I need to realign these grooves with the lugs underneath because they didn't go back in correctly. There we are. Now they're in. Okay, and push them all the way down as tight as you can. And you'll find that in this corner is a black lug. Kind of hard to see, but anyway, there's a black lug in this corner, and there's also another black lug back in this corner, right back in here. And so those kind of keep the board centered within the assembly. And then of course you have the feeling point, or the points on either side of the case that hold it together. Alright, so that's pretty well dry fit, looks pretty good. So the last thing that we're going to do now, once that's all set in place, is we're going to heat these lugs up and solder them, and then I think we'll be done. Alright, so let me kind of zoom in here so you can see what we're doing. Oh, don't want to lose too much focus. Alright. Okay, so that looks pretty good. And so what we're going to do now is take our pencil iron and just a little bit of solder. Doesn't take much. We're not trying to weld the entire planet together here. Again, be careful of the plastic because now you've got this hot iron, and throw a little solder on it, knock it off so it's tinned nicely. Alright, and then what we're going to do is just apply heat to the lug first and get it a little bit warm, and then secondarily to the soldering paste, or the soldering stamp on the board itself. Alright, so there's one in. Kind of blow on it, let it cool a little bit. Looks pretty good. Alright, and again, this can be a source of a problem if you're not real good with soldering. Be very careful because you may want to test solder on some things before you do this. Alright, and then this one here we're going to do the same thing. Kind of warm up the lug and apply a little bit of solder to it, and the circuit board at the same time. A little more solder. And then let them cool. Alright, and I think that's going to do the trick. Everything looks great. You can see the joints are nice and shiny. No cracks. So take a second just to look it over, make sure your work is good. And I think that's going to do it. Now you also notice that the circuit board is much more firm in this container. It's not going to move very much at all, which is exactly what you want. And that also lets us know we have a good solid connection between the lugs on the outside and the circuit board on the inside. Alright, so with that, we'll snap the top case back on it and give it a test run. Alright, now that we've got the circuit board soldered back in place, the last thing we need to do is put the case assembly back together. Now you'll notice this case assembly is mostly plastic. You got a metal plate in here, and you've also got these rubber pads that are I believe designed to conduct heat off of the chips on the bottom and bring them out to the plate and use the skin of the device as a bit of a heat sink. Also, you'll notice that there's 3 light tubes over here, and they correspond with the LEDs inside that are actually mounted to the circuit board. So that's pretty neat engineering on their part. Again, you'll notice that the fingers along the edge of this plastic top part will actually interact and align with the top edge of this piece. So this is where all the fun begins, is to try to get this put back together. Normally it's pretty easy. Again, make sure that the circuit board is all the way down. Again, I've been handling this one, so it's kind of popped up a little bit. Make sure our button's working alright, which it is. And now we should be able to assemble these 2 halves back together. And again, be careful. You have the clips on either side. There's 2 on this side, 2 on this side, and then these fingers up here. I haven't got the plastic pulled off of this yet, but you can see the white fingers actually go inside the case once you get it pushed down far enough. But for the most part, it just snaps pretty much back together again. And it doesn't sound good when it's going together, but if you just squeeze it all together, it goes together nice and clean all the way around. Alright, and then last thing to do is to once again put the screws back in this with your jeweler's screwdriver. And a trick that I found that actually will help you from stripping screws in plastic is once you put the screw into the hole, turn the screw counterclockwise, that'd be to the left, until you hear a snap or you feel it drop a second. I'll do that again so you might be able to hear it. There you go. Once that happens, then turn it clockwise, and what that will do is it'll force that self-tapping screw to go back into the thread that originally was cut for it. If you don't do that, then you run the risk of creating a new thread and cross-threading the old thread that was in there, and plastic being what it is these days, it's not going to allow you to have a good tight fit on that screw if that happens. Alright, and then we have one more screw for this corner, and again turn it backwards until you hear it drop. There you go. And then there we go, and then turn it clockwise and turn it snug all the way down into the thing. Again, you don't want it to be too tight as to cut the threads, but just snug. And that's it. So we're all back together, and we'll do a little test run on it and see how it works. But it looks great, no damage, and you'll never have a problem again with it detaching itself from the power line on the inside anyway. Alright, so that's the TL-PA511. It's a TP-Link 500 megabits per second AC Powerline Ethernet adapter repair. Okay, so we've got the repair done on our TP-Link TP500 Ethernet adapter. It's a Powerline adapter, plugs right into the outlet here. And so the next we need to do is reconnect our Ethernet cable onto the bottom and plug it in. And by golly, we got our lights. Everything's talking. On this particular Ethernet adapter, the light in the center is your speed indicator light, and basically if it's green, it's running at greater than 100 megabits per second throughput. If it is orange, which it is now, it's somewhere, I believe, between 20 and 80 megabits per second, and if it's red, it's 20 or less. And in my particular house, I don't have very good wiring. It's an older home, and so I do have pretty good streaming with media player, not a problem with that. But I see that light, sometimes it's orange, sometimes it's green. Just depends on what else is running in the house and noise on the power lines, things like that. But overall, I think this should work pretty well. The light that you see streaming here, I actually stream video from my TV back to my PCs, and I'm using an old PC TV to go box. It was sold by Pinnacle, and I believe now it's under a different name. But it works really well, and that's what I use it for. Alright, I hope this helped everybody out, and good luck with your repair.